let's consider the function the square of 3x squared plus 2. Notice that when we simplify this becomes 9x to the power of 4 plus 12x squared plus 4. If you want to review on how to square binomial, kindly check the suggested video. So getting the derivative of the square of 3x squared plus 2, this is the same thing as getting the derivative of 9x to the power of 4 plus 12x squared plus 4. This then gives us the answer of 36x cubed plus 24x. If you want to be reviewed on the basics of derivatives, just have the suggested video. Alternatively, knowing that 3x squared plus 2 squared is the same thing as multiplying 3x squared plus 2 by itself, we can actually use product rule and arrive at the same answer. Yes, in doing product rule, we'll have first function times the derivative of the second function plus the derivative of second function this time times the first function. The steps in doing product rule is also being discussed in that suggested video, so if you want to review on how to do this, just click that I icon and have that video. Since our first and second functions here are the same, which would be 3x squared plus 2, notice that our addends 3x squared plus 2 times 6x would be the same, and so we have 2 of 3x squared plus 2 times 6x, giving us 36x cubed plus 24x, which is of the same answer that we got earlier. Observe that if you are going to use power rule in getting the derivative of the square of 3x squared plus 2, our answers would be different. This is where the derivative of a composite function comes in, or what we call the chain rule. Let's apply this algorithm in answering the square of 3x squared plus 2's derivative. Say big F of x would be that function square of 3x squared plus 2. Notice that we can actually have f of x to be x squared and g of x to be that inner function, which is 3x squared plus 2. In this manner, big F of x would actually be the composition of functions f and g, or f of g at x. Evaluating this would give us f at 3x squared plus 2, which is the square of 3x squared plus 2. Knowing that big F of x is actually the composition of functions f and g, we can definitely use chain rule in getting its derivative. Notice that in doing chain rule, we'd be needing the derivative of f of x, or that would be f prime of x, as well as the derivative of g, which is g prime of x. So using power rule and constant multiple rule, the derivative of f and g would be 2x and 6x respectively. Substituting these values, we now have f prime at 3x squared plus 2 times 6x. For the benefit of others, when we say f prime at g of x, it means that whenever we see x this time at f prime, we will be substituting g of x at x. We have a suggested video in evaluating function. Kindly check that if you were confused on this part. Since f prime of x is equal to 2x, x will be substituted this time by g of x, which is 3x squared plus 2. And simplifying this line would give us now 6x squared plus 4 times 6x. Thus, our final answer would be the simplified form of this, which is 36x cubed plus 24x, and it's the same answer that we got earlier. In doing chain rule, identifying the functions f and g for the composition of functions, or identifying what u is, we can definitely apply chain rule just by inspection. For this technique, let's make use of two things. That would be outer and inner functions. To help us more in this technique, let's make use of two colors as well. That would be red for outer function and blue for inner function. Hence, outer function will be about squaring the inner function 3x squared plus 2. In this technique, once you identify the inner and outer functions, we just have to get their derivative. So for this outer function, which is parenthesized terms squared, using power rule, its derivative would be 2 times parenthesized terms. In this technique, we just have to multiply the outer function's derivative to the derivative of the inner function. Hence, we have 2 times 3x squared plus 2 times the inner function's derivative, which is 6x. There you go. This is the same answer that we got earlier. So let's wrap up this technique. That would be the outer function's derivative. In this case, outer function would be the red marks, giving us 2 times this parenthesized terms times the derivative of our inner function, and this time our inner function would be the blue marks, giving us now 6x. Let's practice more. So for this function, the outer function would be the red marks, and its derivative using power rule would be this. Multiplying this to our inner function's derivative, we'll now have this. Simplifying these expressions, we can multiply 4 to the derivative of the inner function's derivative and have this. Let's have some spices and have this function. Notice that in getting the derivative of the outer function, we have to multiply the constant 5 to the exponent 8. So we'll now have 40 here, and subtracting 1 from the exponent, we'll now have 7. And multiplying this to the inner function's derivative, we'll now have this. Simplifying these expressions, we can multiply 40 to the inner function's derivative and have this. Let's widen your horizon by having this function. Observe that using laws of exponents with respect to negative exponents, we can rewrite this function and have this. We have a suggested video on laws of exponents. Kindly watch it if you're interested to learn more of this. Observe that this is actually of the same format that we've been having. So using chain rule and getting its derivative, we'll now have this. So outer function's derivative will be this times the derivative of the inner function, which is this. And simplifying these expressions, we'll now have this. I'll be having a separate video that will discuss on how to use this technique in getting the derivative of trig functions.